Hi, and welcome to another statistics video, the driving force behind statistics. Our essential question, how can I numerically measure spread, is really the big question we're going to be trying to answer in the video. So the first thing we're going to look at is how long do people spend traveling to work with various travel times. So notice I have 15 workers right now that I'm working with, and I have a STEM plot to help us show. So when you are describing data of any kind, the biggest thing you have to talk about is its shape. And I've kind of spelled out a little acronym that says sucks. It's because it truly sucks to have to describe data sometimes, especially because you have to talk about all four of these things. So hopefully on this one, the shape, notice it's leaning toward the lows. In statistics, we don't say leaning, we say skewed. Specifically, this one is to the right, so toward the low ends. If it helps and you're like, how do you know which way is skewed right and left? I suggest looking at your feet. Look at your right foot. It should probably look like that. You got your toe and then you got a little one and then, oh, your little pinky toes. Same thing. You can always do skewed right to get to the other way. Really not too bad. And then on the next one, the U for me stands for unusual features. Unusual features. And this one actually has one major unusual features right here. Notice you have no numbers in the 50s. Those are actually called gaps. And those will kind of appear anytime you have the big jump. And then outliers are another thing that we usually can talk about. We do have a cute little rule for outliers, but that's really not the focus of this video. Next one is center. You have lots of ways to describe center, and it's probably the one you are most familiar with. So you can talk about the average, or you can talk about the mean is another way to describe that. And we usually use this symbol, X, with a line on top. That's actually called X. That little symbol right there is called bar, X bar. No, I'm not making it up, but think of it as you're setting it high. Set the bar high for average. And then the other one is the median, where you find the middle number after putting them all in order. But the main focus I would like to look at is this one, which is spread. It is the biggest thing in statistics that we can talk about, is how is data spread out? Because right now, most of the time we talk about range, the maximum minus the minimum. It's just not very precise. I think we can do a better job. So let's look at why we don't use range as one of our options. Because right here, I made a histogram. And remember, histograms are great to show the shape, but they do hide the original values. Because right now with the driving times, it kind of looks like my range is 63, high minus low. At least with how I've set up the histogram, 60 and 3. Here's the problem. If I go to the other histogram, notice I switched it. We're looking at the traveling times in Austin, 10 and 73. Well, I don't know about you, but it looks like I can just copy the range. It's the exact same one. They both have a range of 63. But I'm pretty sure you can look at those graphs and see these don't have the same spread. So I need to come up with another way to give me one number, just like range does, to describe spread. So maybe I can steal the way that average works. Maybe figure out how far away all these numbers are from the average, like a distance. And maybe find the average of those, which doesn't make much sense. So let me kind of drive this car on over to help you kind of see what I'm talking about. So here's the thing. This number's a little easier. So notice here's the average of 0. Here's all these little distances. So this is 4 away. This is 4 away. Notice all of these are 4 away from the average. Well, here's the problem, though. If I try to find the average of those distances, I don't know if you noticed, but those 4s kind of canceled out. And it gave me a spread of 0, which is not very good because I can't have a spread of 0. That doesn't really make much sense. And I'm really talking about the distances, which for all of these are the same. So maybe I need to do something in math where I can change these little lights right here to something positive because they really are all just 4 away. So maybe you came up with absolute value, which is this option. So notice, okay, we're going to try the same idea. Turn all these positive, since all of those have a distance of 4. Bing, 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 bing. Now I found a spread. It tells me the average is 4. So that would be the spread of this data. What about this data right here? This looks like it's more spread out. That 7 is quite farther away from 0, and so is that 6 down at the bottom. Well, I'm going to try the same thing. Here's absolute value. I'm going to turn all those distances positive. Then I'm going to find the average of those. That's what this is right here. Add them up, divide by how many. I ended up with 4 again. So these have the same spread? Question mark, I'm thinking to myself. No, the distances are very different. Those differences are. So I don't think absolute value is going to work. If only there was a third option in the math world that lets me turn numbers positive. There is. Hopefully you remember it. It is called squaring a number. So maybe that will turn them all positive. So again, here's 4, here's 4, 4. Again, I want to turn them positive, so I'm going to square them. Here's how I found the average. And then I have to think to myself, well, I just squared them. Well, I probably need to kind of undo that operation. So notice here's the square root symbol. Try to undo that, and then I end up with a spread of 4. Okay, let's see what happens with this data set. Again, here's distance of 7, here's a distance of 6. Let me square them to turn them all positive. Then I'm going to find the average, and then making sure that I take a square root right here, because I want to get rid of the square thing. Much higher number. So it's easier for me to say that this one is more spread out. It has a higher spread. And that's a great way to do it. This formula is quite handy. So let's try it maybe with something else to help make sure it actually sticks. So here's the amount of rain in Dallas over the last month, 5, 7, and 12 inches. We're going to try that same exact idea down here, finding the spread of this data. So what I'm going to do first is take this number 5, see how far away it is from the average, how far it deviates from the average. Well, that's a negative number, so I'm going to square it to turn it positive. And then I'm going to find the next one, because I'm going to do the average of all of these differences. So how far is, well, 7 away from the average, which is 8. Square. And it looks like I just have one more number that I'm going to have to do that with. So I'm going to put a little minus sign here, and that would be 12. So how far is 12? Oops, make sure that's in blue. How far is better 12 away from 8? The average, square it to turn it positive. All right, looks like I have 3 observations. And this is the part in the statistics word where it gets a little bit weird, because in statistics, they think it's a little better to overestimate than it is to underestimate. And you'll kind of see why that matters a little bit later. So what we do is just minus 1. And there is another reasoning behind that, but I'm just going to keep it simple by giving you that. And then I need to make sure whenever I get this ugly number, all of this I have to undo. So whenever I get that number like I did above, I do need to square root it to get rid of it. And what we just created here is something called drum roll, please, if I had one, is standard deviation, is what we just created here. And I don't know about you, but that handwriting looks atrocious. So let's just fix the spread on up. Much better, standard deviation, and let's give it the happiness it deserves. Look at that, standard deviation, beautiful. And his definition, or her, is the average, because that's what we did, difference is what we found, or deviations, between each observation and the mean. Much, much easier. And notice this was just 3 numbers, so that is a little complicated. So here's what we're going to do. We're going to give you a simplified formula for standard deviation. And then I'm going to show you how to do this all on your calculator. So S for standard deviation, go figure, equals. And we are going to need a little division sign. And we're going to do exactly what we did above. So we took each individual x value. So I'm going to do x with an I for individual x's, so I know it has to go for every single one. And I figured out how far away that was from the average. That's a spread that literally describes spread, how far away it is from the average. And then I squared it because I wanted to turn it positive. And then it looks like in red, I added all of those things up. So instead of putting a lot of pluses, because I don't know how many, I'm going to use a cute little notation in the statistics world. I'm going to scoop this over so I actually have some space here. And it's called sigma. It's a Greek letter. I'm going to put this over here, so if you would like to write that down. It's called sigma, and it actually just means the word sum. over and over and over again until you are finished. And then we took the number of observations, the last one above, we only had 3, minus 1. And then at the very end, you have to undo the square. So you got to go kind of like going back to the beginning. But we just squared them to turn them positive. And that is what it looks like on a formula chart for standard deviation. Again, pretty ugly, so let's do this in the calculator to help it stick. So in a TI-84 calculator, we're going to do those driving times and put them in. So you have to hit the stat button and option number 1. If you're wondering why option number 1 in your calculator, that is the edit feature. So I'm going to pull my calculator up right here. So here is my list, is kind of where you go. So stat, option number 1 is edit. And I put in all of those driving times into L1. And if you need to, pause the video and go back because it really helps to practice these steps. Whenever you're here, go to the stat button and we're going to go over to calculate because that's kind of what we want to do. And I'm going to pull this screen over so I can make sure I can save it for you. And this is the one you're always going to need. One variable statistics. Every single time is what we're going to be trying to do. And then let me grab this. And then option number 1, and then enter all the way through until you come up with this lovely screen. This screen gives you so much statistical knowledge, it should be illegal, but it's not. So notice already right here, here's the average, 22.47. Oh, minutes, give it some precious units. I gotta know what that 22 stands for. This is minutes, but this is the average. So that's kind of what we did above. So here's X bar. And then the other ones, it gives you kind of some fluff. I promise you don't really need it. But notice right here, S sub X. Congratulations. That is standard deviation. In minutes, it follows the same units. They use S for standard deviation. The one below it is kind of an interesting little creature. I'll briefly explain what it is because you're not really going to be using it much. So I usually have my students cross this out because it's not something that's needed. But if you are curious, this is actually the calculator trying to estimate the population standard deviation. What I mean by population is really those travel times, you only have 15 people selected. I'm pretty sure more than 15 people drive in Dallas trying to commute to work. So this is just a little sample, just a little taste of the population. And your calculator's like, nah, I got you covered. I'm going to check and see what I think the real picture is. But like I said, notice how we overestimated. It's better to over. But not too bad. So I hope you've enjoyed this video and I hope standard deviation is a little bit more clear. And then continue to watch more videos, especially to see how standard deviation comes back and rears its ugly head for so much more. Stay tuned.